Hello Math 152 students. In this video, we're going to take a look at section 9.2 and some StatCrunch tips. So the big difference in 9.2 is now we're focusing on means instead of proportions. Our objectives are going to be very similar. We're going to recap point estimates and look at confidence intervals. And similar to 9.1, I'm going to save this idea of calculating or estimating sample size for you to look at on your own from the textbook. There's some examples, some videos with that are embedded in your ebook. So what we want to do is make sure we understand the difference between a point estimate and a confidence interval. And our definition for a point estimate is going to be the same as it was in 9.1. A point estimate is just a single number that is a statistic. So we could say a point estimate is the value of a statistic that estimates the value of a parameter. So in 9.1, our statistic was p hat, and it was estimating the population proportion p. In 9.2, our statistic is going to be x bar, a sample mean that can vary from sample to sample, and that x bar is a point estimate for our population mean. So one of our goals after we do some examples is to contrast 9.1 and 9.2. Make sure we can pick up on the clues in different scenarios to how we know which case we're in. Let's go ahead and jump into an example for a point estimate. So for this one, we're looking at pennies minted after 1982, and they are made from 97.5% zinc and 2.5% copper. The following data represents the weight in grams of 17 randomly selected pennies after 1982. Treat the data as a simple random sample and estimate the population mean weight of pennies after 1982. So just looking at this data, we do see some variation among the weights of the pennies. Looks like my lowest I see is 2.44, and it looks like my highest, I see a 2.50. So notice there's some variations. It's relatively small. But again, still some variations. So if I look at this and I want to know, well, what is the actual average or the true average of all pennies weighted after or minted after 1982, that's a question about the population mean. I don't know or have access to that information from what I've been given. Maybe somebody does. Maybe there is a true value pennies are supposed to be at and some accepted variation around that, but we don't know that number. So if we wanted to estimate the population mean, the best we can really do is take a look at the average of the data that we were given. In other words, if I just average these 17 values, I'm going to get a number that's a pretty good estimate based on what I know. So if I average those together, I get 2.464. So I could use that as the point estimate for my mu, my population mean. Now, could we do better? Maybe so. Maybe if we had more data, if I had 200 pennies, I might be more confident in my point estimate. If I only have 17, I might be interested in creating a confidence interval. Maybe I am okay with this number, but I want to know a range that would be a good range for my population mean, or a good estimate range for my population mean, I should say. So before we get into some more examples of confidence intervals, we need to think about some conditions and vocabulary. So similar to 9.1, we're going to see the concept of alpha pop back up. We're still going to be using the alpha 0.05 for 95% level of confidence, 0.01 for 99% level of confidence, and 0.10 for 90% level of confidence. Our conditions in 9.2 are going to be a little bit different than 9.1, but the good news is they're the exact same conditions that we saw in Chapter 8 with population means. So let's recap this. And the first thing we have to check is that we have a large sample size or specific conditions are met for a small sample size. So for means, the condition for large is greater than 30. Keep in mind for proportions, it was not greater than 30. We had that n times p times 1 minus p is greater than or equal to 10. 30 is big enough for means. Oftentimes, 30 is not big enough for proportions. So just be careful though. Don't get so fixated on the 30 that you start applying it everywhere. 30 only applies when you're looking at means. So what if you have smaller than 30, like our penny example? There's two options. You can satisfy the criteria if you know the underlying population is normal. So you would have to have that information be provided to you in the original setup, or maybe you had prior data where you could see that the distribution was normal for the underlying population. Or if you're less than 30 and you don't have that information, you need to check your box plot for outliers and your QQ plot to make sure it's approximately linear, and then proceed. Most of the time when we have a small data set, this second condition is where we're going to be. If I only have limited data, I may not know anything about that underlying population. And in fact, when you guys are gathering data, you don't typically, like for your projects, know anything about your underlying distribution, which is one of the reasons that in the project you are encouraged to gather perhaps more data than you might need, because you can run into some blocks with this. If you gather too little data and you don't have a box plot and QQ plot that check out, you're a little bit stuck. You can't proceed. So when you're gathering data or have the option of how much data and its means, shoot for bigger than 30. Right? Shoot for more data than you think you're going to need so you don't get into a scenario of small data set and not checking your conditions. Now, what happens in the real world when that happens? Well, there's going to be some other methods to do estimations, but it's beyond what we'll cover in this course. Another option is if you have small data sets, you might have to think about how to go back and get more data, which might be expensive or time consuming. Looks like I copied the slide again, but let's go ahead and go to your ebook and look at some examples. So let's start by taking a look at problem number 30 with how much do you read? So this one states that a recent Gallup poll asked 1,006 Americans during the past year about how many books, either hardcover, paperback, did you read either all or part of the way through. Results of the survey indicated that X bar is 13.4 books and S, the standard deviation, is 16.6 books. Construct a 99% confidence interval for the mean number of books that Americans read either all or part of during the preceding year. Interpret that interval. So part of the reason I picked this one is the wording is very, very loose. Notice we're asking our participants in our poll to estimate the number of books, right? And then that they read either all or part of the way through. So that's some pretty loose criteria. And what I want to caution you with is be careful when you're interpreting a confidence interval and evaluating it, that you go back and look at how the data is collected. Here, they're telling us that they polled 1,006 Americans, and it's a Gallup poll. So the people at Gallup have lots of resources to design surveys and distribute them. But that's another issue that you might run into. You want to make sure that you trust your source, that you're not looking at a poll that's based off of a convenient sample. It's a reputable source, and that you understand what they asked and like the option answers. So here you could think about this one as, if I started 20 books, got halfway through, I'm going to report 20 books, right? I didn't finish any, but I'm reporting 20 because of the way the question is worded, right? You also want to think about any potential sources of bias. When I read this question, the first thing I thought about is, well, what about ebooks, right? If you're reading books on your Kindle, should I be counting those ones since they're specifying hardcover or paperback? It's not clear on whether the poll wanted us to, right? You might have some people that hear this and think, oh, of course I'm going to include Kindle books, and other people who are going to say, well, it doesn't say that and it specifies these two, so I'm not. Okay, so just keep all of that in mind. When we're doing book problems, we're most of the time going to be running a procedure, cut and dry, maybe making some interpretations. But when you have a more open-ended project, like the final project for the course, you want to think carefully about those issues and make sure that you're sort of addressing those on the front end and not just running this data and making inference too quickly. So let's jump into this one. Notice the first thing, before I create a confidence interval, I know I have an alpha of 0.01 and a level of confidence of 99%. I have a mean from my sample, a standard deviation from my sample, and I have a sample size. So let's go back to our conditions and just recap those, make sure we understand what we need to check. In this case, we fall into our greater than 30 scenario. So there's not much to do other than to note that since 1006 exceeds the threshold of 30, then we are good to go, we can proceed. Best case scenario. Then we're going to open up StatCrunch and take a look at our procedures. So let's go to a blank dataset on StatCrunch. Click over there, and I'm going to adjust my window just a little bit so you guys can see what I'm clicking here. All right, so under the stat, in 9.1 we were using proportion stats. Here the command we're going to be using is tstats. Make sure you read the background information in your book on what this t distribution is and how we are using it. I'm not going to be pulling a lot of questions specifically about the t distribution. There's not a lot of questions specifically focusing on the t distribution in your homework, and certainly not test, but the t distribution is a distribution similar to the normal. It has a little bit more flexibility, so you can read the background information on that in your book. I just want to focus on, once we have that, our StatCrunch procedures. So we are dealing with one sample. We will deal with two sample issues in chapter 11. And in this case, I have a summary of the data and not the actual 1006 entries with the number of books people read. So choose your summary. And then we have the information in our problem to input. Should go back and make sure we verify that. Let's see, so it looks like 13.4, 16.6. And here we're choosing a confidence interval, and they specifically asked us for a 99%. So notice it reports to me the sample mean. The standard error is the same standard error that we were seeing in 8.1. 8.1 was means, 8.2 was our proportions. Here, this is the concept of dividing our population standard deviation by the square root of n. Right? We're not going to be necessarily pulling that very much in chapter 9, but we did see that in chapter 8. Then this degrees of freedom, the DF, is associated with the t distribution. But again, your book talks a little bit more about this concept in the text. Then we have the lower limit and upper limit for your confidence interval, the part that we really want. So notice in this one, we have approximately 12.0 and 14.8. So I could write some sort of interpretation like I am, or we are, 99% confident that the true average of books, either entire books or partially read, that Americans read last year was between 12 and 14.8. So very similar interpretation. We want to state our level of confidence and then make sure we're saying that our population mean is estimated to be between these two bounds. So in our next video, we'll pick up with an example with a small data set.